Welcome everybody again after our short break, and now with me is Johannes Dienst. Hello, Johannes. Nice to meet you.
Hello.
Okay, and we with Johannes, or Johannes will try to tell us something about managed cloud and GitOps. It's really interesting topic for me because on daily basis I'm working with managed cloud teams in our within our company, so it's really interesting. But I have, let's say, kind of open questions to you because I saw your description of your presentation that you had to align to some kind of standards like ISO 2000 and
20,000, yeah.
yeah, exactly. And what is your opinion or maybe your feeling that such kind of standards helps you to be more, let's say, DevOps, to be more agile, or maybe stop you or reduce that velocity of changes, for example? What is your opinion here?
Yeah, for ISO standards, they are very different standards. So
Mhm.
some are quite a pain in the ass, I would say. But the ISO 20,000, there are a lot of best practices in it,
Okay.
and normally you read them up and say, yeah, sure, you have to do that. You have to do testing. You have to do release notes and so on. So normally, if you don't take it's an ISO standard, yeah, there are quite a lot of useful things in there. So I'm
Mhm.
not opposed to them. I'm a friend of those.
Okay, okay, interesting. Okay, so keeping fingers crossed for you and your presentation, and the floor is yours.
So let's see if I can share. I was told Pine is sometimes picky, but it should work. Yeah,
Yeah, we
I
can.
see it. Okay, no. Thanks for the introduction. As you might see, there's a second name on the slides. My colleague Jan is unfortunately not joining us today. He has a personal tragedy to take care of this week. My thoughts and prayers and my love are um, by him. So I will try to fill in the gaps. He's a lot more technical savvy in the later parts of the talk, but I know a lot about it as well. So if you have any questions, ask them if it's not clear enough what I told there. So what I'm talking about today is managed cloud to GitOps. It's a journey from my team, a very personal journey. Over the last 3 years, where we managed to deploy a single cluster in a managed cloud to deploying multiple clusters per customer. We have multiple customers as well in with a GitOps approach over GitLab into AWS. If I say AWS, sometimes it sounds like HWS, but I also mean the AWS cloud. So, what are we talking about? Managed cloud to GitOps, my journey, and let's jump right into it if the slides allow it. Marketing told me I have to market our company. I'm coming from Deutsche Bahn. You may already noticed I'm from Germany. My pronunciation is a bit hard, but I'm smiling, which is not usually the case in Germany. We don't have fun there. Sometimes my moderator said, "Oh, we are timely and punctual, and everything is tidied up." That's not always the case. So I'm quite a funny guy. Marketing said, "Yeah, tell something about our company." Yeah, Deutsche Bahn, especially the subsidiary where I'm working at, DB Systel. DB Systel is a digital partner of Deutsche Bahn. We're driving the digitalization of Deutsche Bahn. If you happen to be in Germany, there's a lot to digitize here in Deutsche Bahn. We have everything, buzzwords from IoT to blockchain to augmented reality, virtual reality, and my favorite use case is predictive maintenance. If you're driving a lot of trains and transport a lot of cargo, then predictive maintenance can save you a lot of problems. So that's it. I have to say, we are 5,000 people, and Deutsche Bahn employs like 300,000 plus people around the world in logistics and transportation. So back to the thing we do at my team. We don't have anything to do with transportation of people or goods. We are building a product called DB Content Hub, and as you already might think about we are building a content management system, but not any content management system. It's bought software we are operating in the cloud in AWS. And this bought system, this make or buy, bought system is the right term here in English. We're operating in a DevOps production model. So we're operating the system we bought, or now it's open source. The talk is based on a bought system. And we are customizing it for each customer with plugins and so on. And the problem with a content management system today is, you don't want to go into a web app and put your content there, but everything needs to have an API, and also our board system here. And we are building also an API around that board system, which does a few extra things, but mainly provides GraphQL and REST interfaces for this board system. So we have a headless content management system. If you haven't heard the term, it's the next big thing in web development. If you have a headless content management system, and we provide content as a service. And content as a service is if you have the content in atomic bits, in atomic sizes, to do multi-channel distribution. So, for example, an app needs some other bits of information and doesn't need things a web app need, for example, or a desktop application. So you have a data model you can define as you will, a very atomic, and then distribute it as you wish. Then we come to the requirements. You may know Deutsche Bahn is heavily regulated, nearly as regulated as financial organizations, I would say, because we have the EBR, Eisenbahn Bundesamt, logistic for railway, state-owned organization, which controls that everything is in order and to regulation. And one of the things we have at DB Systel is that customer, and this is also GDPR compliance, have to be separated physically from each other. So it's not easy to say we build a multi-tenant system and then have there a lot of customers on one system, which would be easy because you only have to operate one system. No, each client cluster, each customer cluster has to operate separately, and if you have multiple systems for one customer, these have to be physically separated on a process level. So this is one requirement. So the requirement from the get-go 3 years ago was, okay, separate these clusters. And then we have the API in front of it. This was a microservice and still a microservice for routing on an API gateway to Business Hub. And if a request comes in, then we distribute it to the separate client clusters. So this is one requirement we had, separation on process level. Then the next requirement, there's where the ISO 20000 comes in. I won't go into detail about the ISO 20000. It's more like a lecture at a university, but there are a few best practices in there, and we as DB Systel are ISO 20000 certified, and we have to adhere to these ISO standard. As you can see, there are a few things in there. You can read it or not, but the main requirement from the ISO 20000, which we have to adhere to as a DevOps team when we operate a system and develop a system, are change management and release management. Change management is if you're bringing changes to production, that it's traceable. There are a few requirements. Actually, this is a best practice. I really like this because if you don't know what comes into production, and I learned it the hard way in the last 3 years, if you don't know what comes into production or what is in production, you have a really, really hard time to find bugs. So traceability is a very hard requirement you need as an operations team. And there comes change management. Release management is also very important, but a lot of people, a lot of you already do this. For example, you write release notes, you make technical tests, you make domain-specific tests, and this all comes under release management. So let's dive into the change management. What does change management actually mean? And this is an extract of it. What we do at the moment, there are a lot of different tiny steps, but you can see it all starts with a request for change. And this sounds big and wow, what have we do for a request for change? It's as simple as a merge request, for example. The request for change is a merge request in GitLab, for example, or a pull request if you're using GitHub. Then you adhere to the requirement from the ISO 20000. And then it gets approved, and then the request for change is okay. And it's traceable because the system like GitLab or GitHub doesn't lose it. Then you have to plan a change, and planning changes often means you have to put it in a centralized repository or a centralized system like ServiceNow. We are using HP Service Manager, I think is the product. Plan the change, and this is also best practice I like, because someone can subscribe to your changes and see, oh, there's a change at Monday next week, but we have a very important production deployment there, and then they can react to your changes. So that's a good thing. Then if nobody objects, then you approve the change in the system, you implement the change, and you do a review. Okay, that's okay. You bring something in production, and then you have to monitor and review if it works correctly. And then you can say, we complete the change in the system. And it's not by chance that this looks like a pipeline. In a DevOps team, you don't want to click boxes in a different system, but a request for change, if you're releasing often, and we are able to release every hour with our system, then you want to have this in a pipeline. So at best, you have an API, and we have that for our service to do all these changes automatically. But they are nice changes to see what comes into production, what caused problems. So traceability is given here, and I like it. Let's go to release management. This is a lot like change management, but a little bit different. This is where you write release notes at first. Yeah, this is best practice. You want to know what's in this as a customer, what's in the change, what's in the new version of your software. Then you test it. Yeah, obviously, you should test it as a developer. Then you have a technical acceptance test. This is something different than a domain acceptance test. The technical acceptance test is if your system runs with this change, and you can spin up a different system for this, or you can use a standing system for this, a dedicated system. For the technical acceptance test, if nothing breaks, so you can also automate this. Then you roll out it, and this is something I don't understand. You roll out, and then you make the domain acceptance test, which is a little bit late, but the ISO says you have to do it that way. Maybe better switch that. And after the domain experts looked at your new system version and say, yeah, that's okay, then you get the clearance and say, we implement it. So, and this is also able to do per pipeline. And as a DevOps team, I strongly recommend that you automate all the tests, even the domain acceptance test, because if you're working in a, okay, I said Jira environment, you can define the acceptance criteria and code it into a test, and then no product owner has to look over it, and you can just accept it if they're green, if they're automated. So let's start with the journey. Oh, I forgot to remove a to-do here, but it's under to-do, so that's okay. Our vision of the infrastructure is very, very simple and not microservice, headless CMS. You think about microservice and so. No, it's plain AWS standard architecture with an elastic load balancer, an EC2 instance, an relation database, an elastic file system, and an elastic cache for better retrieving of information. So that's the vision we're building, and we're building it since 3 years, and that's okay. It's still valid. We changed some components. We configured something in our relation database. For example, we're using Amazon Aurora at the moment because it's a serverless database, and it works better for scaling. But that's the vision, and it suffices. for us. And the fun thing is, everybody says build boring things, they're stable, and we are still happy with it. It's a stable architecture. So let's try our first try of automation in our system was, let's deploy to a managed cloud, and have to define the term managed cloud here. Managed cloud is something like AWS, but with an interface where you can click and point, no automation, just select the server and deploy a dedicated server, deploy a dedicated relational database. So we configured our server, we configured our elastic load balancer, and then we configured these servers. First by hand, then we coded this into Ansible, which is automation for configuration. Highly recommend Ansible for configuration of servers. It makes everything easier and traceable. And we put this playbooks into a Git repository. That's it. And what we did there for deployment was, okay, someone of our team checked out the Git repository on our local laptops and then deployed over Bash the configuration to our 2 servers. This was for our first customer. It's nothing fancy, but it's already automated. We later put this in a pipeline a lot later, half a year later. And let's see what are the pain points of the first iteration. The first iteration is very cool for one customer. It's extremely fast, but if you're downloading and not implementing via pipeline like GitLab CI, for example, then you have some funny things that happen into production. For example, we had a colleague deploying alone the new configuration, and he noticed that a plugin for the content management system wasn't working. Then he patched it on his local laptop and deployed it to production, but he forgot to push it back into the repository. So after 3 or 4 more deployments, we noticed this plugin does not behave like it should, like it's specified in the Git repository. So you have this problem of you don't know where the truth is. The truth is in the repository. And the more fun thing was, he didn't know he patched it, he forgot it, and the code was lost. So we had to redo the code again. If you look at compliance says you know what you're doing, you're adhering to some standards, and you know what is deployed. This is what compliance means here. And security, this is very, very dangerous, because if one employee can check out a Git repository and deploy anything to production, highly risky, and you don't know what and where the truth is. And the truth is not in the repository. And this is very hard to debug if you have different versions on production and in your Git repository. So don't recommend, works for one customer, but when we started to scale for more customers, this wasn't viable anymore. So it's a little bit hard in DBSysTel to get an AWS account, because you have to operate the AWS like a little data center. It's our product owner has to sign with blood that he is responsible for this little virtual private network. But we managed to get an AWS account. It's a little bit restricted. And we said, okay, if we want to do this for more customers, then we have to automate everything. And automation means, okay, deploying not via a laptop, but every time and everything via a pipeline. This is GitLab CI pipeline. You can do it with Jenkins, and it's not limited to any specific technology. And since we are new to AWS, we are using CloudFormation. And to make it easier, we are using CloudFormation in a monorepo. So we have customer configuration there, and we have the pipeline there, and we have the infrastructure there. And then there are some jobs which deploy the infrastructure to the different infrastructure clusters of the customers. Sounds cool in theory and works better than the Ansible approach, I would say, but it has some pain points too. There are advantages. If you're deploying only over pipeline, and I strongly recommend you doing this, then compliance and security becomes much easier because the truth is always in the repository. You can adhere to compliance and say, okay, this is my truth, and it's deployed on the servers. You have to restrict the master access to AWS. Best only readable roles, and don't go there and change manually some things. There's always the danger if you're the master over your AWS account. But compliance and security becomes easier. If you're deploying over pipeline, security updates like AMI updates, Amazon machine images for EC2 become much, much easier because you just bake the AMIs and deploy it over pipeline. And the pipeline, if ran 50 times and you're trusted, you just kick in the pipeline and the security update gets deployed. So it's much, much easier and faster. What we noticed with a monorepo, this might work for Google, but not for our team at that time. It's very hard to maintain. If you have customer configuration, multiple customer configuration for different customers, infrastructure, and everything for pipelines into one repository, there's a high chance that you do something wrong. For example, you want to scale up the infrastructure for one customer because there's a peak in production expected. Then it may be possible you're implementing a merge request for the wrong customer, and it gets overlooked by your colleague because the structure is always the same. The structure in the repository is always the same for the customer configuration. And that happened for us. We scaled to 4 instances, for example, EC2 instances for the wrong customer, and we had a production problem. The load was too much for the customer we wanted to scale for. So difficult to maintain. If you have a very, very high standard, maybe not. But we were newbies at that time, and a monorepo was hard to maintain because the customer configuration is beneath each other and in the same structure. And what we also noticed was we had 2 AWS accounts, one for testing, one for production. The pipelines became extremely complex because we had to differentiate between the customers and the different accounts. So there was a lot of duplication in the GitLab CI definition. So also hard to maintain monorepo plus CloudFormation templates. 2 years ago, we started to say, okay, let's move on from CloudFormation. It's not the right tool to do what we do now. And let's see what can we do better. And there was this new shit then for us, Terraform. And we learned about GitOps, which we did technically, where we say, okay, Git is the truth for infrastructure and gets deployed. So we already did GitOps, but it wasn't working so well with CloudFormation, the monorepo. But Terraform was more or less a game changer, and it looked very easy to specify in a modular way the infrastructure and deploy it. And so we tried it. And what we came up with, and this is we learned later because we didn't know the book, Infrastructure as Code von Keith, I think is the book. I highly recommend it. That this is funnily a best practice to do it this way. So we had a customer repository, and there was also only the configuration there, where we say, okay, so many EC2 instances, this AMI machine image, this version of the content management system is deployed, and this was just a JSON file, basically. And then we have different repositories for the assets. For example, baking the AMIs, Amazon machine images. And the fun thing about these assets was you can bake the AMIs and then just push the right ID to the customer repository. And also with the Docker containers, we Dockerized everything, but we're not deploying to Kubernetes because Kubernetes was too much complexity for us. We were more comfortable with EC2, but that's the next step of the iteration, the 4th iteration, you might say. Every time you bake a Docker, you create a Docker image, you push it to Artifactory, and the right path, the right ID of the Docker image gets pushed to the customer repository. Also with the infrastructure has different versions. It's relatively easy to version Terraform. You just say, okay, this is the right commit hash, and then you can say deploy the infrastructure with this commit hash. So you can pin the infrastructure. Then we also have extensions for the content management system. Also just deploy a new version to Artifactory and then get it when you want to deploy. And everything in only the configuration of all these different components are in the custom repository. So you have this nice separation of concerns. You can build everything independently and also deploy them independently. So you get a lot of freedom to do the right thing and don't depend on, for example, if a new Docker image is created, you have to deploy it immediately and don't know what's up. You can do it for each customer and see what happens there. So when you want to deploy the new infrastructure, for example, or a new version of your content management system, AMI image or extension, then you trigger a pipeline in the infrastructure. So we tie the GitLab CI pipeline. I don't know if this is a best practice, but it works well for us with the infrastructure. So the pipeline works for a specific version of the infrastructure. And this runs a GitLab CI pipeline and deploys the infrastructure, symbolized by an EC2 icon here. Now the ISO and some security problems come into place. For example, traceability of secrets. You have to change secrets. You have to rotate the secrets. This is a little bit problematic. GitLab CI offers the mechanism of CI variables, or GitLab variables, I think they are called. And you can change the secrets there. You can put them in there, and the secrets get deployed to the GitLab CI pipeline, and they have access to it. This is a little bit problematic and also not ISO 20000 conform, because you have to trace the changes. You have to know when the secrets changed, to know if a bug happens, what caused the bug. So what we do, and GitLab supports this not only with our solution, but for example with Ansible Vault, or I think there's a vault for HashiCorp for secrets, and you can decode secrets from there, so they're traceable. We put all our secrets into the secrets manager. This is this new symbol of the secrets manager, and the GitLab CI pipeline reads them with a specified job, and then we have it in the GitLab CI pipeline. So it's suffices for our requirement that the secrets are traceable. This is very important. Let's see what the advantages. I see I have a lot of German headings here, so I'm sorry for that. I had to rework some of the slides from German to English. So the third iteration has not only advantages, but most of the advantages we needed here. We have a configuration repository for the customer, even for the different, let's say, dev, test, and prod environments, and only the configuration. And it's modular. It's a simple JSON file for us, so you can do it in YAML as well. And you see the truth. What is deployed for the customer lies in the repository, which helps us to fulfill all the requirements for ISO. We have traceability for our operations. We know what the customer has in store, where are the bugs, and where we have to fix it with the right versions of all the assets. So this is a cool thing. Only the configuration in one customer repository, and it's also best practice. We learned later. So best practice always have configuration in a customer repository. The updates are thus extremely simple. You just change the IDs, and you can do this automatically if new security updates for your Docker container or your AMIs come, are produced by your other pipelines in the other repository. You can do an auto merge in GitLab, and then you already have the updates and just have to click or you can say deploy automatically if you're very confident in your pipelines. So what we have is we deploy 2 times a week the new baked AMIs, and we usually don't have any security findings in our systems. If you're operating in AWS, you know there are security findings every day for AMIs. So we are not safe every day. So we had to deploy every day, but sometimes this is too much. But usually we have to fix security updates if they're not internet facing in about 3 days. So that's okay. The customer configurations are separated cleanly. So for every customer, we have a dedicated repository, and what we'll see later, we have different branches for each environment. 3 are possible at the moment. So if you go into development, you're deploying to development environment. If you go to main, you deploy to test. If you go to production, you in the production branch, you deploy to production. So it's differentiated cleanly. And for our team, which is a complex deployment, it's easier to manage. So if you're more in control, if you have a better overview over your pipeline, you may do this in one branch, but it works better for us in that branch. We have autarkic clusters. I don't know if this is a term in English, but autarkic was what DeepL pointed out. Every cluster is separated cleanly on a network level, so on a thread level, even physically, every stack is autarkic at the moment. So we fulfill the requirement of autarkic and physical separation of our clusters. And potentially, if we beef up our deployment a little bit, we can have a potentially any number of stacks for each customer. So if you need more than dev, test, and prod environment, we can spin up everything you need for each customer. And I bet there will come a customer who needs 5 or more environments. So everything is possible now. We are very, very flexible with this approach of different repositories. Third try, I have to say something about our deployment process and our branching strategy. We are using the GitLab Git flow. Yeah, that's the term. It's easier than the Git flow model. We have a development, a main, and a production branch, and everything in every repository flows from development to main or to production. So we're able to test all the changes in development and then merge them to main, test them there, and then we're going to production. And this is through our monitoring stack, through our asset stacks, and through our customer repository. So they are cleanly differentiated. So every time you work on a specific branch, you know, okay, I'm working for this environment. And I highly recommend this GitLab flow because it's easier to manage than Git flow, in my opinion. We tried that before and it didn't work out that well. And we are now very happy if we go to development, we know, okay, this is for this environment, and it makes it very clean. And after 3 years of DevOps, where you have to manage so many things and so many different technologies, simplicity is key to keep operating nicely. So let's see how the pipelines look. You may see our board product we had there, if you look closely. And we are using GitLab CI, and we are using child pipelines. They are relatively new feature. I think there's a 1-year-old, heavily, where we trigger pipelines in another repository, and GitLab detects, okay, this is a child pipeline because it's triggered. That works over the API of GitLab. So if you trigger development, if you trigger a development deployment, then we have a job. We can also trigger a cluster single. We have a single and a cluster version of our product. So this is should be a cluster. You can see it, a cluster deployment. Then we trigger it in the custom repository, and this triggers a pipeline, a child pipeline in infrastructure in the same branch. And okay, it's a cluster deployment, and then okay, the cluster deployment knows I'm on development, and then it triggers the deployment on IRT. This is a functionality in GitLab CI, and it triggers another downstream pipeline, a child pipeline. And this is standard Terraform. It's not not too complex, but you see the whole infrastructure there. There's validation. Then we plan the Elastic file system, the Elasticsearch cache, and a relational database. And then it gets applied. And after that, then comes the deployment of our content management system, which needs all the different infrastructure beforehand. And this is just a Docker container, which is configured and run correctly. So this is a quite complex pipeline. If you want to trace some things, GitLab is not too easy to navigate at that part, that they're getting a lot better with every release. But child pipelines are still a little bit messy to handle. But we are very happy with it because now it's traceable where the pipelines get triggered and how the flow is. So I mentioned we are a DevOps team. DevOps team at DB System means you're also doing operations. This is the part where Jan normally steps in because he built the monitoring stack. So forgive me if I'm not too accurate there. You can ask the questions and I hope I can answer them. Or you can email Jan and ask them about it. We're using a standard stack for monitoring. It's baked into the AMI with sidecars. We have a Filebeats installation on every AMI, every EC2 instance we deploy, and we have a Prometheus exporter for metrics of the EC2 instance. So this collects the log files, the beats, and there with the Prometheus exporter, which collects the metrics of the EC2 instance. And the log files go into Elasticsearch, which are searchable through Kibana. That's okay. And the metrics get exported to Grafana. And we also have an alert manager. I think this, I'm not sure if this is a part of Prometheus. Don't nail me on that, please. And you can define alerts in Grafana, but we noticed that the Grafana alerts aren't that good for us. We're using the alert manager. And the alert manager alerts us about possible high CPU load, running out of space on the SSDs and so on. So this is our monitoring stack. Only downside of this stack is that we cannot create automatically dashboards, Grafana dashboards, which are nice to read for every customer. We have to do some manual work. So this is something we should improve on that part. But the nice thing is if you bake everything into an AMI and configure it with and start the Docker, the sidecars, the beats and the Prometheus with variables supplied by the GitLab CI pipeline who deploys a customer, then the customer EC2 instance already has the right tags, the right configuration, that in Kibana you see the logs separated for each customer. And this is a very, very nice thing to have. So you just spin up a new customer and it automatically is searchable in Kibana. So highly recommended to do that. So I see you're 2 minutes, and that's okay because I don't want to bore you anymore with details about ISO 20000. I think you saw that ISO 20000 is achievable change management and release management with the pipelines because we have pipelines and can do everything in those pipelines. And as I said before, we are able to physically separate the clusters, which is a high requirement for security and data protection. Let's wrap up the advantages. Creating new customers is simple. They get easily into the monitoring. You create a custom repository. You can create a custom repository with a pipeline, just supply a few variables. This is what we have done. And it gets created via GitLab API. And you have the configuration with the newest updates and the right branches. Hands-free rolling updates. Yeah, if you do everything via pipeline and it's configurable as highly configurable as we did it, you just click the pipeline and the updates roll through in best way possible. Automatic connection, I already set to monitoring, and compliance and security updates. This was a major pain we had, are easy if you have a pipeline. You just have the assets, build the new assets, deploy them, and the security updates are already deployed. That's cool. Another wrap up. We have challenges. We have a lot of Git repositories. You saw we have those repositories. We have a lot of custom repositories. They are complicated. It's a complicated interaction. We would like to have this in a better overview. So we say we can't manage this in GitLab anymore if there are a lot of more customers. So we are building a central management tool called Spot, single point of truth, where we just abstract over the GitLab API. A single web application where we can see what is deployed where in a human readable format, where we aggregate the most important information. And I think I'm on time and ready for questions.
Yeah, exactly. You are on time. So thank you for your great presentation. And yeah, we have one question on our Q&A chat. So isn't the only way to have the truth in the repository to use something like Nix OS? Otherwise, you're just depending on abstraction platforms that pretend to have immutable state, but actually just hide it from you with automation versus an actual immutable OS.
Okay, I have to say I don't know exactly what NixOS is, and that's the thing. Christian, I see the question now. We hide the fact that it's mutable. That's right. But we are strongly advised not to go into AWS and on the server to change anything. And we learned that the hard way. We burned ourselves a few times. And actually, the last year nobody went into production and changed anything. So I'm very happy that that didn't happen again.
Yeah, it's great to hear that no one clicked directly something on server or write some command.
Yeah.
It's great to hear that you
And
achieved.
I'm fault of this. I took down the production with a click, so it's possible.
Yeah, great to hear that it's possible. It's possible to achieve kind of utopia in many places. Yeah, because I saw many organizations that we wanna to have something like this, but they are that few years later at the beginning of that adventure with transforming, because I believe that it equals to transform the whole organization, not exactly, not just okay, we are starting to do that, but I think that you had to change your mindset also to deliver the infrastructure, deliver the application.
Yeah, but thanks for the suggestion. No, that's a hard word. I will look into NixOS if that's immutable. So thanks for that.
Okay, so you answered my question, my personal question from your presentation on that last slide. What are, let's say, the current your current challenges and current plans? But you told us that you are developing kind of web app which allows you to manage customers and configurations in the easier way
Yeah,
than
it's
of
very hard to manage in GitLab. It's possible, but the overview in GitLab is
Mhm.
not as great as I wish it was.
Okay. Okay. So thanks, Johannes, for your great presentation. I think that everybody enjoyed that really. So yeah, now we have lunch break. So we will see here within an hour on the last two presentations on our architecture and DevOps teams track. And again, thanks, Johannes, for your presentation. I really enjoyed, and I also grabbed a few things from it to my, let's say, daily work. So thank you for your time and for your speech.
Great to hear. I'm just sharing experience. If you want to connect, I usually only retweet, but you can connect with me, and I'm always open to chat.
Yeah, absolutely. I always love to hear about the practical examples, because theory is the theory, but the practical things are showing many bottlenecks with the theory. Yeah? So it's always good to see the practical example. So thank you again, and of course, I would like to invite you also to our last two session today. So we will cut within an hour. See ya.
Bye.